welcome to our clinic. Okay, now I checked earlier today the Google sign-up sheet. There weren't any questions there, but since I don't know how to get there from this machine, I'll just skip it, but I'll pause and ask, are there any questions up front at this point? I have a piece of paper here to scribble something down in case there are. No? Okay, then we'll jump right in. Last week's highlights, nothing really earth-shattering. We still have the VFD Swimmer Beta 2 open for testers. Feel free to go there, check it out, but it's going to be in 1.13.2 coming out, I think, late July or early August. So I know that the integration, the merging is going on with develop at the moment. So that should be available soon as part of develop. Jumping over to the forum, there were a few interesting developments. Number one, remember that thread where someone was seeing drops in performance going from 1.8 to 1.10 or 1.12. And we had that resolved because it turns out there was a patch that hadn't quite gotten merged yet into 1.10 or 1.12, or the version of 1.10 or 1.12 that the person was using hadn't gotten that patch yet. But that was resolved, so we are back to 1.8 performance. But then along the way, we discovered that that user was actually using chunk size 1, and that's usually not a good idea. And interestingly enough, he tried this and he provided this table that I copied here that just illustrates this in a way, the metadata overhead that you incur versus the data that you actually store if you choose chunk size 1. So the first column here is really the chunk size number of elements. I forgot, it was probably an integer type or something like that in this case. And these are the actual data bytes that he stored, and or this is sort of the data footprint reported by H5stat. I have to be precise here. And this is the metadata size in bytes as reported by H5stat. And as you can see, just bumping up the chunk size drastically reduces the metadata footprint. Of course, that's not going to continue forever. And also you can see that this is for uncompressed data. So since the user wasn't writing, I think he was writing order tens of thousands of elements. So this is probably realistic here. But for this one, there would be a lot of fill values in these chunks. And so, yeah, there would be quite a bit of, so most of that chunk or a large part of that chunk would actually be occupied by fill values. And had he applied compression, that would actually go away. Yeah, so at some point, the metadata overhead, so to speak, reaches a steady state. And that can be nicely seen in this table. There were also a few comments from Stephen, who did two things. Number one, he provided, since he saw that pattern where the user seemed to be acquiring data of some kind of sensor network or sensor feeds or something like that, and he commented that that was a kind of a typical pattern in a variety of applications. And he suggested that it might be more efficient, especially when he wanted to use some concurrency, multi-threading, for example, to have a dedicated I/O handler. And he actually provided an example. One, if you want to implement that with multi-threading, to have a multi-threaded queue. And he linked that code example. And then on second thought, and here's a typo, there's one N too many, that for other reasons, it might also be helpful to actually decouple the data recorder and the data generator and the data recorder, or the sender and the receiver. And since this application was written in Fortran, he was so kind to actually provide a sample data generator or a sender in Fortran, and he uses to do that decoupling 0MQ. And the receiver is written in C. So not only does it decouple the two, but it also gives you that additional flexibility that if you have different constraints in which language, for example, or in which framework you are implementing these things, then that might be an additional benefit. Okay, any questions about that? No? Okay, then I will just continue here. The other interesting thread that was going on, remember there was this user who was using file images, and we had sort of a little bit of a difficult time to reproduce his issue, but we finally got it baked. And I'll come back to that in a second. The first observation, he was also reporting that he said when he used, I believe, 112, that there was a tremendous slowdown. And the reason for that, I believe, is that in his callback, sort of in the beginning of his code, he iterates over a file, over the links in a group, in the root group in this case, and then basically has a callback function, and he basically looks, well, if this thing is a group, then he wants to do something, but if it's not a group, he's not doing anything. And he uses to determine or ascertain the type of the object that link has its destination. He uses H5O get info with the H5O info all option, which in this case is not a good idea because first of all, H5O get info is a very expensive call because it tries to sort of harvest all that metadata, including potentially access time, object types, and all kinds of low-level metadata. If you specify H5O info all, that will make this extra slow. In his case, since he has that switch statement in there where he only checks, well, is the type of this object a group, you can get away. There is an option called H5O info basic, I believe, and that sort of doesn't try to harvest all this low-level metadata, and it's going to be much, much quicker. And I think that should resolve this performance problem. And this is something that I believe that was introduced. H5O get info is a macro, and I think we are up to H5O get info 3 at this point. I think it was introduced in H5O get info 2, but in all newer versions, these options are available, so that you can tailor how much work you want to do to get certain metadata. And then he also, in his example, at some point, he has a comment where he says he's surprised where he reads using the core VFD an HDF5 file from disk or from the file system and creates a memory image. And he said, well, he would expect that if he does like a listing in LS and sees how many bytes, what's the size in bytes of that file on disk, he said, I would expect that if I create then an in-memory buffer of that same file, that the length of this buffer in bytes should actually be the same as the length of that file on disk. And that's not the case. The reason being that usually when you use the core VFD, you specify the increment by which you want this buffer to grow if you are modifying this file. And unless this increment divides the size of that file on disk, it's very unlikely, well, in fact, it's impossible that the length of the two would be the same. So what the core VFD will actually do is create a byte, create a buffer size that is really a multiple of this increment rather than what you specified or what it finds on disk. And so with these two comments out of the way, the real issue is, and I'm a little surprised that he wasn't able to produce this error message, but when I run it, I get this error message, and yeah, there's a lot of uninteresting stuff here. The interesting stuff is actually down here at the end, where it complains about a metadata checksum. And if you think about it, and this is for the super block. I can't, oh yeah, I have to, yeah. It complains that it's not able to sort of match that checksum to the super block that it read. And what's going on here, I believe, and I have to check this with the developers, is that, and by the way, this happens only if he says he uses this file access property list where you get, where you can set libvirt, and then you can set it earliest and latest or latest and latest. So this occurs only if he sets the lower bound to libvirt latest. And the reason I believe this is happening is that if you look in the file format specifications in versions 0 and 1 of the superblock, there was no checksum of the superblock. However, in version 2, I believe, and then we carried that over into version 3, we added a checksum to the superblock, so to speak. And what I believe is going on here, since he is creating this file image from the core VFD, what happens is, despite that he does a flush before he creates the file image from that in-memory file, so to speak, he does a flush. And however, that flush is not triggering that. I think that would also be a very expensive thing if we did this on every flush to, although, well, the superblock can always change. But so what is not happening is, as a result or as a side effect of that flush, that checksum is either not updated or not updated quite yet, because I could imagine that the library would defer that to the situation when you are closing the file, because it might have to do truncation, and because the end of file is also stored in the superblock, that would of course influence that checksum. So maybe in this particular instance, this is sort of a corner case where, well, yeah, if you create a file image from a in-core scenario, that unfortunately, if you, in combination with this file access property list of libvirt latest, you trip over that issue. But that's just my hunch. I don't know, Quincy, do you have a comment on that?
This sounds like a bug. It's like, if you've actually done the flush, it ought to, anytime an entry is evicted from the metadata cache, the checksum has to be updated correctly. So I agree with you that it may be a issue with the end of the address space, the EOA in the superblock, but still believe that's probably a bug.
Okay.
It may be simple enough to track down and figure out, oh, okay, I see, but it doesn't look right. Okay, great. Yeah. But at least we have a hot lead now because it's just agonizing to find. But yeah, I'm somewhat surprised he said he didn't get an error message, because yeah, this pops out immediately. Anyway, good. Okay, any other questions on that? No? Okay. Then there was another interesting thread. Somebody was talking about using the read-only S3 VFD. This is something we introduced quite a while ago. It is read-only. However, so the use case for this is, let's say you have an HDF5 file and you just store it as a blob
in S3, in AWS S3, then this virtual file driver gives you the ability to actually read from this file as you would just do an H5F open and H5F read and whatnot, and everything works great. And that works for blobs that you have stored in a publicly accessible bucket. However, it also works if you pass on credentials. So let's assume this is a bucket that is not publicly accessible. You can specify there on AWS, there are these secret keys and secret IDs, and you can specify them as part of this access property list, but then also the command line tools such as h5dump and so forth, they expose that through these options such as --VFD to tell the library that you want the read-only S3 VFD, but also then there is this option -S3 cred where you can specify that bucket is going to live in a certain AWS region, and then the secret key and secret ID. And but the user was commenting that he couldn't get this to work with H5Py, but it turns out that maybe he just didn't dig deep enough. First of all, if you use H5Py, definitely with the current version, but since the S3 VFD has been around for some time, at least 2 years, if not 3 years, you can definitely specify a non-POSIX virtual file driver in the file object in H5Py. But furthermore, as part of that keyword list, you can also specify these S3 credentials if your HDF5 file does not reside in a publicly accessible bucket. And I put the link here to the H5Py documentation. So that's well documented, and the user actually found it himself. So that's good. And it is also true that nowadays, since the S3 API is kind of the de facto standard for a lot of S3 compatible object stores or storage options out there, it works also with non-AWS S3 storage, as long as it's reasonably S3 compatible, whatever that means. And yes, so I can remember we also tried that with a colleague, and we found that works. So yes, that's good, and it's not a surprise. We knew that, maybe we don't advertise it. But yeah, so the read-only S3 VFD does not work exclusively with AWS S3, but pretty much any kind of S3 compatible storage. And he was also asking, and we created a GitHub issue for that currently HSDS is available on, or this feature is available on S3 and S3 compatible storage. I believe in the Google Cloud GCP, they also have an S3 compatibility mode, and so does Azure. But it could be, there could be some issues here that have to do with the nature of these compatibility layers. But then there is also a he had a question about HSDS, so the highly scalable data service is currently available, yes, on AWS and yes on Azure, but he was looking for an HSDS build on GCP. And yeah, so at this point, this is an enhancement, a GitHub request. I don't know, yeah, I'm sure John Reedy will reply at some point. Just making it work based on the S3 compatibility, because obviously there's Kubernetes, or there are different ways, maybe that's what I should say first. You would first have to think about, well, what kind of HSDS deployment do you want? And if you want Kubernetes-based HSDS deployment, Kubernetes is certainly available on GCP. And then it hinges kind of on an S3 compatible storage backend, but if it's true that there is a GCP S3 compatibility layer, then definitely getting this off the ground shouldn't be too difficult. But then I don't know, maybe John knows what the potential overhead for that compatibility layer is. So if you want to make that really go smoothly, then it might be better to, rather than using this compatibility layer, to go directly to the Google, whatever the native way of accessing their object store is. And yeah, but I'm sure, yeah, if there's sufficient interest and maybe someone is willing to sponsor this, we can try to talk to Google maybe, then we can maybe get that going, maybe even before the end of the year. Any other questions about this or anything else? No? Okay. Then for today's tips, tricks, and insights, I have something not exactly technical, but something that I do that sort of I draw a lot of inspiration from is you sometimes might ask yourself, well, first of all, since we are fortunate that HDF5 is really, and also HDF4 is widely used, people do lots of cool things. And you find out about that at conferences, in publications and whatnot, but how do you really keep track of these things? And what I found very helpful to just sort of get an idea of the diversity and the breadth and the depth of what people are doing with HDF5, I recommend either just do a search on Google Scholar. So if you go to scholar.google.com and then type in HDF5 plus your subject, it could be a specific domain science like particle physics or high energy physics, or HDF5 and neuroscience. And I almost guarantee you that it's harder to find a term that you put in there combined with HDF5 that doesn't return any results. Typically you get hundreds, if not thousands of results, and then you have to trim down the maybe the time frame during which you are interested in citations. But if you find that interesting and you just want to sort of see the trickle of new citations coming through, you can actually create an alert for yourself. And basically there are 3 fields that you have to specify when you create such an alert. The alert query, and for me it's just plain HDF5, but then again, if you are interested in a specific domain, you would add that to your alert query. And then I think there's documentation on if you have a more sophisticated query rather than the straight sort of ending of these search terms. You can definitely fine-tune that. You provide an email address at which you will receive emails with these alerts. And then you have a choice between, I think, most relevant results and all. And I signed up for most relevant results, and I had pretty good success with that, in the sense there are definitely no false positives, in the sense that I've never received an alert for a citation that didn't mention at least once HDF5 somewhere. And but I could imagine that the volume would be much higher if you, I mean, you can try all first, and then if that's too much, you can just trim it down to most relevant results. But yeah, I had pretty good success with that. And what happens then is you will typically get, I would say 2 to 4 emails per week. And each of these emails will contain about 6 to 10 citations that could be conference references to conference proceedings where people have given a talk, publications in journals, in online journals, technical reports, all over the place. Sometimes also just a technical report from a research institute, the whole gamut. Very interesting. And just, yeah, since I had one this morning, I always like to read through them. I just picked a few highlights here to just give you an idea of the types of citations that you will be seeing. So for example, here's one citation, and again, it's hyperlinked in here. You can click on that and see the exact citation. This was something that came through. There is a famous Monte Carlo n particle transport code, that's that MCNP. And so this was just a short technical note that came out where the two authors, this is a code, I believe, maintained by researchers at Los Alamos, where they basically describe that an HDF5 file is created during this transport problem, the time stepping, and then how to interpret, how to extract certain subsets from that. And I included the link to the Wikipedia article that describes that code in greater detail. It has to do with neutron scattering, and it's used in all kinds of different analysis contexts. That's one. Here's another one, a good one, and I'm not reviewing these articles here and so forth, but just to give you a flavor here, this is actually an old problem. I've worked on that problem a little bit myself, and so I'm always interested in seeing what kind of progress people are making. This was an interesting article, I think, that was just published at CC Grid, maybe, towards a practical provenance framework for scientific data on HPC systems. And I just sort of copied a few sentences from the abstract. So the authors are basically, they are looking at 3 specific simulations just to get an idea of what type of provenance is really needed. And then, the reference model sort of in web space is the W3C provenance model. And however, in this discussion, the authors concluded that this model is just too general for typical scientific applications. And so it doesn't really do justice to this diversity of I/O operations. Then, of course, there are greater opportunities in this context to automate or to mechanize a lot of this provenance generation, and such as the creation of these RDF, that's the resource description framework, in which you can express these provenance, call them statements or facts. And then finally, of course, you would then like a user engine to query and visualize that provenance. Again, there are generic tools out there, but in this case and in this context, I think you can do better with something customized for this use case. So that's another very interesting one. Here's something out of the artificial intelligence, or more the scientific artificial intelligence space. It's been known that, I mean, in enterprise space and industrial space, people do machine learning with the sort of standard tools. But what's also known is that the standard tools like TensorFlow and whatnot, they do not support out of the box scientific data formats such as HDF5 and PNetCDF and AWS and whatnot. And so what the authors of this paper set out to do, and they have a specific type of neural network here in mind. It's fill flooding, or it's a distributed fill flooding or flooding fill network. It's basically one of these neural networks that you can train if you use high resolution tissue, medical tissue imagery, and you would like to separate sort of voids from actual cell structures. So you want to detect cellular structures. You use these FFNs, And in this case, they consume HDF5 data. And the authors are basically saying, well, if you carefully craft a pipeline where you extract the HDF5 data, do some transformations maybe, and for example, convert them to TensorFlow records or something like that, you can actually achieve very good performance with these sort of tools that do not support these scientific formats out of the box. And they have some performance results in there and so forth. So if you're into scientific AI applications and so forth, this might be an interesting read. And I have to hurry. Here's another one. If you are interested in digital twins, as of late, there are a lot of papers coming through on the digital twin side where you have basically a physical system and a sort of a digital system, so to speak, and you feed the digital system real-time data sometimes from the physical system, and in some cases you make control decisions for that physical system based on the digital twin of that physical twin. These authors here use, as they say, they use some of the more advanced features, so-called such as Swimmer and so forth, to see real-time data in a graphical user interface, to SHM, I think that's structural health monitoring here. So there are digital twins for all kinds of things, from airplanes to bridges to all kinds of engineering structures. And again, it's very interesting to see how broadly HDF5 is used, whether it's biology or physics, or again, if you go to scholargoogle.com, just type in HDF5, maybe combined with your domain, and you will get sort of a wealth of information. And unfortunately, there's so much coming through, it's impossible to keep up, even if it's just per week, maybe a few dozen new citations. Unfortunately, we all have to work jobs and we can't spend the time to sort of really read everything in great detail. But it's good as we absorb a lot of information by just being aware of what's coming through, rather than sort of going out there and digging down in depth. And anyway, next time, I couldn't manage to do it for today. I want to talk a little bit about data type conversions and show a little bit of code example, of course, unless there are other questions. And yeah, but that's for next time. And so yeah, sorry for the hiccup today. Hope we can work out the audio issues. And thanks for coming. And please come again next time, and enjoy the rest of your day.